Hi there. In this video, we are learning about sine function and transformations that are associated with the sine function. Now we are graphing sine function, all right? And our entire focus is how does the graph look like? How is it obtained? What are some of the basic characteristics of the graph and so on and so forth, all right? We have to begin with our handy dandy unit circle. Just a quick reminder, unit circle, all the inside ones are the degrees right here. Then the middle circle represents all the radian values for the same degrees. So 150 degrees basically corresponds to 5 pi over 6. 45 degrees or pi over 4 basically is the same as 45 degrees. Then the other thing is that each of these theta, both of these are basically theta. One theta is in degrees, the other one is in radians. Both of these, the theta has a corresponding x and y coordinate and then tangent value also given. So real quickly, this is what we did earlier. Let's say you were asked, hey, what's tangent of 3 pi over 4? Now you have two choices, either to use a calculator or unit circle. If you use your calculator, in this situation, your calculator needs to be set up in the radians so you can get the correct answer. If you choose to use unit circle, which will go by faster in this case, 3 pi over 4 is right here. This is the entire information that's associated with 3 pi over 4. Tangent is the one in green, so this is simply -1. This is what we did previously. Moving on, how is all this stuff associated with the sine? Now, if I take theta and graph it with respect to the sine value, I will end up with sine graph. What do I mean by that? For example, let's say this is your x and y coordinate. X and y axis. Right? Let's say on the x-axis I graph theta. Let's say this is 0 in radians. Let's say this is pi over 6, pi over 4, pi over 3, pi over 2. From the first quadrant, let's say I choose 0, then I choose pi over 4, then I choose, let's say pi over 2. Okay, what's the corresponding value of sine? At pi over 4, at 0 corresponding y value or y coordinate or the sine value is 0. So the point will be 0, 0, and I plot that point. At pi over 4, which is what I chose next, pi over 4 corresponding sine value will be root 2 over 2. Root 2 is 1.414 divided by 2, so this will be definitely less than 1. If this is 1 and this is -1, this value will be somewhere here. Next, pi over 2. So if I go to pi over 2, that's my theta, and sine value there is 1. So my corresponding point will be pi over 2, 1. Pi over 2, 1 is right here. If I continue doing this, let's say my next is, let me pick the middle one, so 3 pi over 4. Then the next one, let me pick pi. Oh, I didn't mean to do that. There we go. I just meant to erase the x and the theta and that. There, perfect. All right, the next one, 3 pi over, I already got that. So let's say, and then I pick the middle one, which is 5 pi over 4. And then I want to pick 3 pi over 2. And if I pretend I continue this, then I have 7 pi over 4, and I'm just choosing the major ones. And back to 0, which can also be referred to as 2 pi. So let's continue our graph. 3 pi over 4 corresponding y value is, again, root 2 over 2, so it's going to be the exact same as pi over 4. At pi, corresponding sine value is 0, so back to here. 5 pi over 4 is to negative root 2 over 2. So 5 pi over 4 would be negative root 2 over 2, just less than 1. 3 pi over 2 is exactly -1, so this one will be right at -1. 7 pi over 4, again, negative 2 pi over 2, somewhere here. And when I get to 2 pi, which is the same as 0, then the corresponding sine value is back to 0. Now if I connect these dots, make it bigger. Now when I connect these dots, I have actually graphed the sine graph. This is the equation of y equals sine theta or sine x. or sine t, whatever that variable is, this basically represents your x coordinate in correspondence to your y coordinate, right? And now this was one revolution. If I continue with these revolutions, if I continue going, so this was one revolution, right? If I continue another revolution, what will happen? The same value is going to start repeating itself, right? So I can predict what's going to happen next. And honestly, if I start rotating backwards, counterclockwise directions, same thing. So this graph goes on forever in both directions. However, I have highlighted one period or one rotation or one cycle, which is the frequency of the graph. So this is the graph of our sine trig function. And I just kind of explained here as to how it is derived from that unit circle, from the values of sine at those corresponding theta points. Now, having said that, now that we have a function in front of us, functions always have some characteristics that we generally talk about. For example, what's the domain of that function? What's the range of that function? What's the domain? What's the range here? Is this an even function, an odd function, or neither actually? It could be none of those. We discussed that early on in Unit 2 and Unit 3 when we were talking about polynomial functions and rational functions. The other thing could be, what is the maximum value and where does it occur? What's the minimum value and where does it occur? What's the period of this function? Period means how often does it start repeating itself, right? Let's start with the domain. Domain is all the x values, as you know. Now, since this goes on forever in both directions, you can say that it can take any value for x. There are no breaks, no holes, no asymptotes. These are the nice continuous functions. The domain will be all real numbers. The other way to write that is going from negative infinity to infinity, and infinities always have curved parentheses around it. Speaking of range, range basically is you're looking at how high does it go and how low, or what's the maximum y value that this function can take, or what's the minimum y value this function can take, and everything in between. So you can see how this goes all the way to 1, and the minimum value is negative 1. So negative 1, comma 1, both will have square brackets around it. This is the interval notation. As set notation, I would say y less than equal to 1, greater than equal to negative 1, and then y, and then the curly parentheses. Sorry, it kind of got squeezed in, but these are two separate ways of writing the range. Then speaking, is this an even function, an odd function, or neither? Then I have to review with you real quick what even functions were and what were odd functions. How do we recognize them? Even functions are symmetric with respect to y-axis. They have y-axis symmetry. What does that mean? Y-axis symmetry would be if we have a graph that goes this way, then there will be a reflection of that exact same stuff over y-axis. Exact same stuff reflected across y-axis, and this is an even function. Odd, on the other hand, if I have the same kind of stuff going on here in the first quadrant, then you'll see a reflection about the origin. That's the definition of odd functions, which means whatever's in the first quadrant, there will be a reflection of that in the third quadrant. This is what an odd function is. So if you look at the sine function here, again, keep in mind this is your x-axis and this is your y-axis. This is the origin. So everything that's in the first quadrant, you can clearly see there's a reflection of that in the third quadrant. And anything that will be here in the second quadrant, there's a reflection of that in the fourth quadrant. So our sine function is an odd function because it's symmetric with respect to the origin. Maximum value is 1. However, that maximum value, it occurs at pi over 2, as you can see. Then it'll occur again at this corresponding value, which will be pi over 2 plus 2 pi, which is 4 pi over 2, and I did that to make it the same. The next one will be 5 pi over 2. And this maximum value will keep occurring, right? Because it's a periodic function. If it's repeating itself, if the cycle is continuously repeating itself, then the max will keep happening, not just at one spot. This is not the only spot of max. This and so on and so forth. And to find the next one now, I'll keep adding 2 pi to it. Why 2 pi? Because the period of this function is 2 pi, which means it repeats itself every 2 pi. So that's that, all right? This is the second slide. Hope you kind of understood how this is derived from the values of theta and the corresponding values of sine at those theta. The other thing you want to notice is that this right here refers or is called the amplitude of the wave. And amplitude of the wave is the height of the wave above the average point, and the average point is basically the x-axis. That's the average. From the average, it goes up 1 and goes down 1 from the average. That's the amplitude. The other thing you want to know about waves or periodic functions is that they have a set period. And the period, this right here, is the period of this sine wave. That period, as you can see, lasts from 0 to 2 pi. So for sine, this period is equivalent to 2 pi. That's not the case necessarily with all the other 6 trig functions, but for sine and cosine, they both have the same period, which means they repeat themselves after every 2 pi. And those two things. Okay, we have already discussed this. So bottom line, here is the sine function. The period is 2 pi, the amplitude is 1, goes over above 1 unit over x-axis, 1 unit below. Some characteristics of our sine function. Again, remember this is our parent function for sine. Y equals sine of x. This is the parent. And from the parent function, we can derive transformations. What were the transformations again? If you remember, if you recall, transformations are some of the words that were frequently used with transformations were reflections, rotations, sliding or translation. Translation basically means slides, like horizontal shift or vertical shift, which means the shape stays the same, but we're just sliding left, right, top, down, that kind of stuff. And then dilation, of course. Dilation is also referred to as shrink, horizontal shrink, vertical shrink, or stretch, horizontal stretch or vertical stretch. Okay, that's associated with that. So this is the second topic, transformations. Again, keep in mind, the parent function of sine is y equals sine x. However, if there are transformations associated, then we end up using a, b, c, and d. A sine b, x plus minus c plus minus d. So what are these a and b and c and d? What are the jobs of these 4 letters here? Because if I remove a, b, c, and d, then I'm back to the parent function, if you notice. The only difference between these two is the introduction of a, b, c, and d. And there could also possibly be a negative in front of it. Now let's explain what's what. If there's a negative, that means our graph has reflected over x-axis. If there is a negative. If there's no negative, then there's no reflection associated. A refers to the amplitude of the wave, of the graph. B, on the other hand, is basically 2 pi divided by the period of the function. And for that matter, I can switch the value, the positions of b and p. P can be found by 2 pi divided by b, and b can be figured out by dividing 2 pi by p. So depending, if p is given, then we use this one to find b, and if b is given, then we use this one to find the period of the function. C is referred to as the horizontal shift. It could be left or right. Shift. So left would be positive and right would depict negative, and I'll show you with examples. And the last one, D, which is also usually the relatively easier one, is vertical shift. If there is a vertical shift up or down, this is either up or down of the graph, then we have values for D. If there is no vertical shift, if there's no horizontal shift, if there's no change in the period, and if there is no change in the amplitude, then literally we go back to the parent function. All right, based off of this, we're going to now start graphing transformations of sine graph. Okay, so we're like, oh, I got to graph y equals 3 sine x. So obviously when I look at this, here's the parent function. I can clearly tell that this is not a parent function, right? The equation given to me is not a parent function. The only slight difference is the 3. So what is 3? Is 3 A, B, C, or D? Now again, I can write this several times for you. Plus minus D. And you can clearly say that A is 3. And there is no B, no C, or no D, which means there's no vertical shift, there's no horizontal shift, there's no change in the period. There's the only change this equation has as compared to the parent function of sine is that the amplitude is higher. It's not 1, it's actually 3. So 1, 2, 3. This is how high my wave goes. 1, 2, negative 3. This is how low my wave goes. All right. But since the period is the same, what's the period of parent function? It takes 2 pi, 0 to 2 pi for it to complete 1 revolution. So I'm going to mark 2 pi. Half of that is pi. Half of that is pi over 2. And right here, 270 degrees is referred to as 3 pi over 2. Since there's no change in pi, I kept 2 pi as 2 pi. 0. These 3 points will be there. Will be the x-intercepts. No other change. All I have to do is make this go up to 3 at that half mark, bring it back to 0, then make it go down negative 3, and then bring it back to 0 at 2 pi. Okay, so there's no shrink, no vertical stretch or shrink involved because B did not change. Okay, and of course this will then continue forever in both directions. That's why I highlight one cycle. All right, here's the next one. I gotta graph this using transformation, so I'm like, let me compare this to the parent. Parent is sine y equals sine x. So what's different here? The two different things different. One, there's a negative in front of it. Now if you remember that negative, the job of the negative is to reflect the function across x-axis, not over y, across x-axis. So my function is not going to be reflected. And not only that, if I compare it to the ABCD types, I'm sorry, the ABCD transformed sine function equation, I can just use minus and plus as well. There is an introduction of B which is different from 1. So A is still 1. Graph is definitely reflected. I gotta keep that in mind. B is 2. C, no D. Okay. Once I have this, I should be able to graph it, but do I know the period of this function? Not anymore, because since B changed, automatically P changed as well. So I can find P using this simple equation or formula. 2 pi and B is 2, so P is pi, which means the new period is pi. It's not 2 pi anymore. It's going to complete one cycle in just pi. So I'm going to mark half of that, and half of that, which would be between pi over 2 and pi would be 3 pi over 4. And you can look it up on your unit circle. And 0 is 0, and this is the end of the cycle. So keep the cycle in mind. The cycle is still the same. Goes up, goes down, and comes back here. But the period is not 2 pi anymore. As you can see, period is now pi, which means I have to still complete that one cycle, but in pi amount of time. The other way to look at this is that, as you can see, this is sine 2x, which means this wave is going twice as fast. If it's going twice as fast, it's going to complete one cycle in half the time, right? Now I'm about to graph it. Goes up to 1 and negative 1 because there's no change in the amplitude. And I start graphing it, but I'm like, whoa, wait a second, I have done something wrong. I did accommodate 2, but I did not accommodate the reflection. Reflection means instead of going up first, now it's going to be reflected over x-axis. So here, half point, bring it back. Then the other half of the loop, stop right here. This is the original. this is the original little cycle of the graph that was given to me, and then from here it'll continue in both directions, and I have graphed what was given to me. You can see, compare this to the parent function. Since there's no c, there's no shift in this, it starts at the same point. However, because the period is different, instead of one cycle ending at 2 pi, that one cycle is ending at pi. And the other thing was the negative. Instead of going up first and then going down, this one goes down first, halfway through it comes right back at 0 and then goes up. All right, those are the only two differences. And we can keep introducing A, B, C, and D. If all four are present, the more complicated the graph gets. Let's compare this to A sine B x minus C plus D. So what all do I have? A is clearly 5, so this wave goes pretty high. And then we do have B as well. And if you remember earlier, I just told you, if there is B which is greater than 1, then this is telling me this is even faster wave. It's going 3 times faster than the parent. What was the parent again? Stuck to 0, 0, up and down, 2 pi. This completes one cycle in 2 pi, but my current wave, which is 3 times faster, it's going to cover the same cycle in a third of the time. So if you divide this by 3, that's going to be the cycle of it. Anyway, let's go systematically. So A is 5, B is 3, and as you can see, C is still 0. There's no C or no D. Okay, now since I have B, I'm going to find the period, which is 2 pi over B. So those are two differences. Number one, 5, negative 5, and one cycle is completed in 2 pi over 3. So half of that, which is pi over 3, and then it's still stuck here. So no reflection, goes all the way up to 5, halfway through it comes back to 0, then repeats it but in the other direction, and boom, done. In other words, you know how this the parent one completes one cycle at 2 pi? This one's 3 times faster, so within that 2 pi, it's actually going to complete 3 cycles. 1, 2, 3. Fast wave. Higher frequency, shorter wavelength, if you've taken physics. And the last topic is, can I do backwards? If given a graph, can I come up with an equation? Because over here, we were given an equation, and we were trying to come up with a graph. Can I do it backwards? I can put an equation together if I know A, B, C, D. Same. If I can find A, B, C, and D, then I can put together an equation. So amplitude, that's how a wave goes from 2 to negative 2, but it's wrapped around x-axis. So the amplitude is definitely 2. Then comes in P. Period here is, you can see, is marked 4. So period is 4, then B is 2 pi over P, which is 4. Pi over 2, so B is pi over 2. C, which is the horizontal shift. As you can see, if I were to highlight one cycle, originally in my sine parent function, graph passes through the origin. And this one does pass through the origin as well, so there's no horizontal shift. None. D, on the other hand, is like, is my graph still wrapped around x-axis? Because that's what parent function is. Parent function is wrapped around x-axis. If it's still wrapped around x-axis, it really hasn't bumped up or down. So D is 0 as well. There's no D. And once I have A, B, C, D, I'm just going to put them together. Oh, wait a second. You see how it goes up and then down? This one goes down and then up, so there has to be a negative to accommodate that reflection. Sine B, don't forget the x, and then C and D are non-existent. So here's the equation of this graph. Well, next example, can I put together an equation for this? I'm like, yeah, amplitude. Is this still wrapped around x-axis? Yep, it's still wrapped around x-axis. So 3 up and 3 down. Okay, P, what is period here? 1. Okay, period is 1, so that means no change in B. B is 2 pi over 1, which is still 2 pi. All right, C is the horizontal shift. And is there a horizontal shift? How do I know? Again, I keep drawing the parent function. The parent sine function passes through the origin. Does this pass through the origin? Nope, it does not pass through the origin, which means it has translated to the left or to the right. I'm going to go find to the left. Looks like it shifted to the left. because this is one complete cycle, as you can see, right? But it shifted to the left. How much? 1/4, and that's what that C is. D, this is still wrapped around x-axis, so there's no vertical or horizontal. There's no vertical shift. Now that I have A, B, C, D, I'm gonna put the equation together. A sine B x, and then plus here. I'm over here. I got the B, X, and then C. Because it's to the left, left means positive. By the way, let me put the parentheses there. And then D is basically 0. I don't even have to write that. So here is the equation of the graph that was given to me. And we know this is the sine function, and hence we are accommodating sine to begin with. All right, and these two look like they're the same. So what is this asking me? The graph of this may also be obtained using transformation. So we have this here. Let's see if we can identify amplitude, B, C, and D for this. Amplitude should be a no-brainer now, 3. Now, if you notice how the equation that I gave you every time that involved A, B, C, D, B was always outside in the parentheses, outside the parentheses, right? And that's B. If B is distributed, then we cannot find the correct value of C. And in this equation, B has been distributed. B is inside the parentheses, and hence I cannot find the correct value of C. So I have to undistribute this 2 and bring it out here. Then start parentheses. Why? Because you have to compare it to the standard form. Minus, now if you want to put a pi here, that would be incorrect, because now when I distribute, I'll get 2x and then minus 2 pi. But we never had 2 pi to begin with, so that would be wrong. So the right way to do that is to put a 2 over this. So whatever you pull out, basically, make sure you put it in the denominator of this value, so that when we distribute, we get 2x, and when we distribute it here, then we get negative pi. We can't change the equation. We can just write it in a different format. Now you can see the B is 2. There's a C, which is negative, means to the right. Pi over 2. So there is a phase shift, horizontal shift, pi over 2 to the right. And D is non-existent, which means the graph will still be wrapped around x-axis, no jump up or down. However, amplitude is higher. What's the period? If B is 2, then period would be 2 pi over 2, so pi. And there is a phase shift to the right, pi over 2. So this is going to start at pi over 2. Instead of starting at the origin, it has shifted to the right, pi over 2, okay, with a period of pi. So if it starts here at pi over 2, then the period is pi, and I have to add that to the starting point so I can get the correct ending point. Now I can't add these two fractions unless they have the same denominator, so I'll have to do this. This is 3 pi over 2, so that's the ending point of one cycle. Now I can mark the half, and half of half, and 3/4. And once I have that, then remember this is the starting point, this is the middle, that's the end of the cycle. I have to make it go up to 3 amplitude, and halfway through bring it back to 0, and make it go to -3, and then bring it back here. And then of course you can see it as continued, but you can see how it does not pass through the origin, because there is a horizontal slide or horizontal shift, which is to the right, pi over 2. If this made sense, if this last example made sense, be very proud of you, because that was a tough one. Anytime there's C, it leads confusions. All right, so that's it for here. What did we do in this one? We first introduced ourselves to our parent sine graph. which is basically graphing theta and the values of sine to that corresponding theta. When we do that, we end up with a nice little wave for sine graph. Sine graph, parent sine graph always passes through the origin. Its period is 2 pi, which means that's how long it takes to complete one cycle. And then it repeats itself on both sides. We need to be aware of what the amplitude is, and amplitude is always calculated from the average. And then the period is considered to be, another name for period is frequency or cycle. CY, well, I can't spell cycle. There, cycle. Referred to, all these three are referred to as P. And then the domain, range, and all that stuff, odd even functions. Once we got comfortable with the parent function, then we started transforming sine function. And that one big equation for that is the one that involves ABCD, the job of ABCD, and what effects do they have on the graph of the parent function. All right, this should be it. I will see you next time when I see ya. Bye.